Hello everyone, and welcome to ILAN Technologies presentation on IPv6 in DrayTek routers. My name is Java, like the coffee, and I'm a technical sales specialist at DrayTek Australia and New Zealand. In today's agenda, we're going to start with some IPv6 basics, including what it is, and a breakdown of the IPv6 addressing protocol. Then we look at how DrayTek routers can help with the transitioning over to using IPv6, IPv6 WAN and LAN, and some other IPv6 features. Okay, let us start at the basics. So, what is IPv6? Internet Protocol version 6 is an addressing protocol that will meet the future demands for IP addresses. IPv4 has served us well, but when it was developed, no one had any idea that the internet would become what it is today. And now we're starting to get close to running out of unique IP addresses. One thing you notice right away with IPv6 addresses though is why are they so long, and what's with all those letters and numbers? What do they mean? So IPv4 gave us 32 bits or 4 octets of binary numbers, which equates to 4,294,467,295 unique IP addresses. The reason IPv6 addresses are longer is because now we get 128 bits or 16 octets of binary numbers. That gives us, well, just a few more unique combinations. That's 340 undecillion, 282 decillion, 366 nonillion, 920 octillion, 938 septillion, 463 sextillion, 463 quintillion, 374 quadrillion, 607 trillion, 431 billion, 768 million, 211,000, and 456. Phew. One other problem with having 128-bit numbers instead of just 32 is that it creates really long strings of numbers in binary format, that is, combinations of ones and zeros, which is the format that computers and routers need. However, these are difficult for human brains to comprehend, not to mention time-consuming to write. So to make things easier, we represent IPv6 IP addresses in hexadecimal format instead, which gives us 8 sets of 4 hexadecimal digits separated by colons. Each hexadecimal character represents 4 binary characters, which we can see in the table on the right. 1 to 9 in hex are the same as the decimal versions, but then 10 to 15 are represented using the letters A to F. So if we look at the first octet of our example, IPv6 address here, A524, we know that A is 1010, 5 is 0101, 2 is 0010, and 4 is 0100. To explain the difference between hex, binary, and decimal a bit further and how to convert between them, decimal uses 10 as a base, so we have 10 unique characters to represent any numbers. That's 0, 1, 2, etc., right up to number 9. Binary uses 2 as a base, so it only uses 2 characters. That's 0 and 1. Hex uses 16 as a base, so we need 16 unique characters. Hence 0 to 9. And then the letters A, B, C, D, E, and F. So if we take a decimal number like 5432. Another way we can look at it is that it's 5 times 1000 plus 4 times 100 plus 3 times 10 plus 2 times 1. Another way we can write that is that it's 5 multiplied by 10 to the power of 3 or 10 cubed plus 4 multiplied by 10 to the power of 2 or 10 squared plus 3 multiplied by 10 to the power of 1 plus 2 multiplied by 10 to the power of 0. Hexadecimal follows the same principle except using lots of 16s instead of 10s. So if we go back to our hex number of A524, we can find out its decimal value by adding A, which from the chart we know is 10, times 16 to the power of 3, plus 5 multiplied by 16 to the power of 2, plus 2 multiplied by 16 to the power of 1, plus 4 multiplied by 16 to the power of 0, or 10 multiplied by 4096, plus 5 multiplied by 256, plus 2 into 16, plus 4 into 1, which comes to 42,276. I'll leave that on there for a moment. Just the basic thing to grasp is, in a 4-digit number, whether it's hex or decimal, the first digit is multiplied by the base number cubed, second digit is multiplied by the base number squared, the third is multiplied by the base number to the power of 1, and the last number remains unchanged because any number to the power of 0 is always 1, and any number multiplied by 1 remains the same. To convert binary into decimal, which we know is base 2, the same principle applies. So that is 2 cubed, then 2 squared, and so on, which works out to 8, 4, 2, and 1. If we take a hex character like A, which we know from the table is 1010 in binary, we have the equation 1 multiplied by 8 plus 0 into 4 plus 1 into 2 plus 0 into 1. We can discard the two 0 values in red since they come to 0 anyway. So we're left with 8 plus 2, which equals to 10. Okay, so that hopefully explains why those hex characters in IPv6 addresses mean and how they can be converted to decimal or binary. Don't worry too much if you didn't understand all of this, because the table on the right will be the most you'll ever need, and there are plenty of calculators available online if you ever need to convert hex to binary into decimal or vice versa. There are also a few shortcuts we can use to make IPv6 addresses shorter. To begin with, leading zeros in a quartet are optional. For example, the quartet is 08A5, can be shortened to just 8A5, and a quartet of zeros can be shortened to just 10. Successive quartets of zeros can be represented as 2 colons. Bearing in mind, this method can only be used once in an address. For example, here we have 8 zeros in orange. These 8 zeros can be replaced with 2 colons, so it looks like this. To expand IPv6 back to its original format is basically a reversal of the same procedure. In each quartet, add the leading zeros as needed until the quartet has 4 hex digits. If a double colon exists, count all the quartets and replace the 2 colons with multiple quartets of zeros so that the total is 8 quartets. Let's look at some examples of network ranges for expanded, abbreviated, prefix lengths and device range in subnetwork of IPv6. In expanded notation, all zeros still exist, while in the abbreviated notation, the leading zeros are removed and the 4 quartets of zeros are replaced with 2 colons. In prefix length, we simply add /64, which represents the global routing prefix and the subnet ID. And then lastly, the device range in subnetwork. Let's now look at the terminologies used to describe IPv6 address classes. Global unicast addresses are much like public IPv4 addresses. Unique local addresses are like private IPv4 addresses. And link local addresses are IPv6 addresses that are valid only for communication within a network segment. Link local works like APIPA, that's automatic private IP addressing, that's used by Microsoft Windows, for example 169.254.224.212. We can tell which is which by looking at the first digit in the address. Global unicast addresses always start with a 2 or 3. Unique local begins with FD. Multicast begins with FF. And link local begins with FE80. Just like IPv4, there are different parts or groups of an IPv6 address. The first group is the global routing prefix, which is the first 3 groupings of numbers or first 48 bits. It's also called network ID, used for routing. The subnet ID is the 4th grouping of numbers, that is the 49th through 64th bit. This identifies the subnet within a site and functions like subnet field of an IPv4 address. And the last part is the interface ID, which is the last 64 bits that acts like the IPv4 host field. Now we look into IPv6 features and advantages. These include global reachability, simplified header. It eliminates the need to use NAT or network address translation, auto configuration, and no broadcast. Let's go through some of these in a little more detail. In IPv6, every device has a unique IP address and they can directly communicate with each other over the internet. IPv6's header has been simplified to 8 fields. As you can see here in the legend, 3 field names in yellow are retained from IPv4 to IPv6, namely version, source address, and destination address. 7 fields are not kept, and 4 fields were renamed and repositioned. And lastly, 1 new field called flow label has been added. IPv6 addresses do not need NAT anymore, because now we have more than enough addresses to supply the demand for each device that connects to the internet. There are 2 types of auto configuration. Stateful auto configuration is when a computer obtains IP address from a DHCP v6 server, while stateless auto configuration the computer will assign its own IP address. IPv6 supports both stateful and stateless auto-configuration, and these complement each other. A computer can use stateless auto-configuration to configure its own IP address, while it can also use stateful auto-configuration to obtain other information like DNS IP addresses. IPv6 no longer uses broadcast. Instead, it only uses unicast, multicast, and anycast. This means it no longer affects the performance of the host or computers in the network. Using broadcast caused the network interface card to interrupt the CPU each time, and all the PCs in the network had to process the broadcast even when the message was not intended for them. Let's now have a look at DrayTek's IPv6 transition strategies. Dual stacking is an integration method in which a router has implementation and connectivity to both an IPv4 and IPv6 network. This is the recommended option and involves running IPv4 and IPv6 at the same time. DrayTek provides an additional memory stack to handle the IPv6 related traffic and services. This dual stack functionality enables DrayTek routers to handle both IPv4 and v6 at the same time. The online status page in the router will show both the IPv4 and v6 network status. For example, IPv6 PPP requires a dual stack router to work. For our RSP to provide an IPv6 address, we need to configure our IPv4 WAN connection to use PPPoE. Then under the IPv6 tab, we just need to select connection type PPP. No other setting is required in the router. Now here's a short video showing how it's done.
In this video, we are going to configure IPv6 on the Vigor router using PPP mode. In our setup, we are using a Vigor 2860 and our RSP is internode. First step is to enable IPv6 feature via RSP. For internode, we will need to access and log into their website to activate the IPv6 service. The second step is to enable IPv4 internet connection. So internode uses PPPoE for authentication. From the router admin page, go to WAN, Internet Access, and select WAN 1 Details page. Select Enable and make sure that VPI is 8 and VCI is 35. Enter the username and password provided by internode and then click OK to save your settings. The router will need to restart to apply those changes to take effect. The third step is to verify the IPv4 internet connection. To check the IPv4 is working, go to Online Status, Physical Connection, and look for WAN 1 status. As you can see under WAN1 status, the uptime is 24 seconds, so IPv4 internet connection is now working. The fourth step is to configure IPv6 PPP mode. Go to WAN, Internet Access, and select WAN1 IPv6. Under IPv6, select the connection type as PPP and then click OK to save your settings. The router again needs to restart to apply those changes to take effect. To check if the router has assigned IPv6 address, go to Online Status, Physical Connection, and select the IPv6 tab. As we can see, IPv6 is up in about 11 seconds. The last step is to test IPv6 connectivity to the internet. To test it, we will go to Diagnostic, Ping Diagnosis, select IPv6, and enter IPv6 address as ipv6.google.com, and then click Run to execute the ping. Thank you for watching the video.
Tunneling is an integration method in which an IPv6 packet is encapsulated within another protocol, such as IPv4. This means adding an IPv4 header to the IPv6 packet. It includes a 20-byte IPv4 header with no options to the IPv6 packet, and it also requires dual stack routers. An example for tunneling IPv6 is 6-in-4. 6-in-4 is a transition mechanism for migrating IPv4 to IPv6. It also uses tunnels to encapsulate IPv6 packets over IPv4. In this mode, the IPv6 connectivity is provided by a tunnel broker on the IPv4 internet connection through a tunnel configured manually. To use 6-in-4 static tunnel, you need to sign up for a tunnel broker service and get an IPv6 address and routed IPv6 prefixes first. Then configure the router as follows. Set connection type to 6-in-4 static tunnel. Enter the tunnel server's IPv4 address in remote endpoint IPv4 address. Enter the router's IPv6 address in 6-in-4 IPv6 address. Enter the routed IPv6 prefix in LAN routed prefix. All of this information that I mentioned will be provided by your tunnel broker after you sign up for the service. Now let's take a look at DrayTek IPv6 WAN connection type. DrayTek supports two types of IPv6 WAN connections: tunneling IPv6 and native IPv6. Native IPv6 is normally provided by your RSP as an additional service, as we saw in the video. DrayTek supports PPP, static IPv6, and DHCPv6 for native IPv6, just like IPv4, which uses PPPoE, DHCP, and static IP connection types. This will require dual stack routers. However, if your RSP can't provide native IPv6, then you can use tunneling IPv6, which requires signing up with a tunnel broker. The tunnel broker will encapsulate the IPv6 packet by adding an IPv4 header to it or mapping an IPv4 address to an IPv6 address. Moving on to IPv6 LAN. Under LAN general setup in the router, we see that there is an option for assigning IPv6 addresses for LAN clients. We'll also need to select the WAN interface that has IPv6 service available, as well as DHCP-v6 service. Quickly looking at DrayTek's other IPv6 features before concluding today's session. IPv6 addresses are also supported by firewall filters. So even without NAT, the PCs are still protected by the router. As you can see here, we can select IPv6 groups and objects for filtering. And lastly, we can also implement QoS based on IPv6 addresses. All right, so in summary, today we discussed IPv6 with hopefully a reasonable explanation of what it is, why it was necessary, and what the IP address looks like. We looked at how to use DrayTek routers' dual stack capabilities to help implement it, and the difference between native and tunneling IPv6 on WANs, how to implement IPv6 addresses on LANs, and how IPv6 can also be incorporated into DrayTek router firewall and QoS rules. That is it for me, but please do stay tuned. Staff will be answering questions in the live chat that's on the right of your screen for the next 5 minutes. For any more information about DrayTek products, please do check out our website www.draytek.com.au or send us an email to sales@draytek.com.au or just give us a call on 0298 388 899. Don't forget to like and subscribe below. And if you'd like a notification of new premiere videos we're about to launch, or anytime we put up a new video, please give the bell a click too. Thanks for joining in. Thanks for your time. Bye-bye for now.